Hi, I'm Jonathan Palmer, the Chief Executive of Motorsport Vision, the company that operate the FIA Formula 2 Championship. In fact, this car is our Formula 2 car. It's designed by Williams, the Formula 1 team. We as Motorsport Vision actually assemble the car, and it's our team that prepare the cars. We transport them, take them to each race. We're here at Monza now, and it's our mechanics and our engineers that run them for all the 24 drivers in the championship throughout the whole year. So let's have a closer look at it. The car itself is built to the latest safety standards as required by the FIA. It's a composite, that's carbon fibre tub. Well, by tub we mean the actual centre chassis. It's a pretty straightforward layout like any other single seater. So obviously the driver sits in the middle, legs go up between the front wheels. Behind the driver is the fuel tank, and behind the fuel tank is the engine, and then finally the gearbox, and obviously drive shafts, hubs, etc. Now the Formula 2 car is powered by a 425 horsepower turbocharged 4-cylinder engine. It's based on the Audi 1.8 20-valve motor that we and our engine developers Mountune have really put a huge amount of work in to change the power from an engine that is originally only producing 150 horsepower. That's what the turbo Audi engine produced when it first came out. But to make an engine that can reliably run to 425 horsepower all the time, and 480 horsepower when the drivers push the overboost button, means a great deal of work. It's a huge stress on the engine, as you can imagine, and 480 horsepower from just 1.8 litres is an incredible demand on an engine. Well, let's have a look more closely at how the engine fits in. This car here shows the layout. The engine cover is off it, so you've got the 4-cylinder engine. Now that bolts onto the back of this composite chassis. The chassis being composite is very, very rigid, and that means that there are considerable challenges on the whole engine from vibration. Essentially the air comes into the engine through the air inlet, it goes into the turbocharger, into the intercooler, and then into the engine, and then ultimately the drive comes out of the back of it. So that's how it's located in the car. You've got the gearbox hanging on the back of that with the drive shafts coming off. But we can have a closer look if we go and see an engine actually prepared, and a spare engine that could potentially go in one of the cars. Electronics form a major part of any contemporary racing car, and the electronics are very, very sophisticated to enable this engine to run to the level of power and for the endurance of it. Ultimately, you can see at the back of the engine a flywheel that looks a lot smaller than anything on a road car. You want to reduce the amount of inertia to the absolute minimum so the engine revs up as quickly as possible. The clutch too is a much more sophisticated affair. It's a triple plate clutch, again one that's much lighter, much more compact than you find on a road car. The demands on the engine really are absolutely huge. You know, as we said, this engine in a road car configuration was originally designed to produce 150 horsepower with its turbocharger. The higher performance versions of it in the Audi range got up to 225 horsepower. But a road engine, in truth, very rarely runs at maximum power. A lot of a life of a road engine is spent cruising along inevitably, and particularly, of course, the higher powered cars. Apart from taking those cars on a circuit, there just isn't the opportunity to drive them hard on the public road to really stress them. Racing environment, though, is completely different. Of course, every time the cars are out on track, the throttle is floored. They're delivering maximum power when the car's accelerating, otherwise they're being slowed up when the car's braking. So big demands, just purely from the amount of throttle usage. But then of course is the state of tune. To take this engine from 150 horsepower, 200 horsepower perhaps, to an engine that can reliably produce 425 horsepower with peaks of 480, and again when the driver pushes the button on the steering wheel he gets overboost. For a 6-second period he'll get 480 horsepower. It means quite substantial changes to the engine. What stays the same? Well, the actual cylinder block it's an iron cylinder block. That remains the same. The basic head design remains the same. But apart from that, pretty much everything else is changed. The crankshaft is new, lighter weight, stronger. The connecting rods, the pistons working their way up through the engine. The valves are a different material. The camshafts are different. This engine in road form would rev to about 6,500, maybe 7,000 RPM. in the racing engine in the Formula 2 unit, it'll rev to 8,500 revs with a power band between 7,000 and 8,500. The other big challenge is that in the Formula 2 application, when cost is driven down to the minimum, but it's still expensive. A season of Formula 2 costs £275,000 for a year's running. It's a lot of money, but nevertheless a lot cheaper than perhaps the £1.5 million it takes to run a GP2 team. So to get the cost down as far as one possibly can, the engines are designed to run for a full season length. And that's about 4,000 miles. So this engine has to produce that amount of power but not require a rebuild for 4,000 miles. Formula 1 engines, when I used to be in Formula 1, would only last for about 500 miles before needing an expensive rebuild. Formula 3 engines typically produce 220 horsepower and they need rebuilding after 1,500 miles. So big demands on this engine. And it means, of course, that the quality of the components has to be very high, the quality of the assembly has to be very high, particularly the quality of the lubricants has to be very high. The lubricants, of course, are absolutely essential to minimise the wear, enable the engine to cope with the mechanical stresses, the thermal stresses, and we have the very best products that Comma can supply, and they do an outstanding job for us. So back to the car itself. The level of monitoring of these cars is extensive. There is so much sophistication on it. The technology is very highly stressed. To produce a 400 plus horsepower car from 1.8 litres and be driving it absolutely flat out is very demanding. Every time the car comes back into the pits, the engineers will be plugging in the data monitoring equipment, looking at literally hundreds if not thousands of parameters, trawling through the data, looking for any sign of anything not being quite right, and then of course, if that is the case, getting on and getting the engine cover off and fixing things. But the engine is a key part of the car, and most of the data logging does revolve around the engine. But further to that, there is of course data logging on the chassis for things like brake line pedal pressure, the steering wheel angle, G sensors left and right, and as well as the road speed, the air speed, and all of these throttle position, turbo boost. And these are the sort of parameters that the driver, with his race engineer, will be going through to see, so the driver can see how he can improve his performance, and whilst the engine engineers are looking to see how their engine performance is going. But that's something, of course, the driver wants to take completely for granted. Each of these Formula 2 cars has one top-line mechanic who looks after that car, both back at the workshop at Bedford, but also here at the racetrack. And then we have another hit squad of mechanics in the event of a serious problem, an engine problem, a transmission problem, or of course an accident, more likely. That hit squad of 3 or 4 expert mechanics will then descend on the car to help the Formula 2 car's basic mechanic do his job. The level of speed and accuracy of working is in another league. These cars have to be turned around from major shunts potentially, or an engine change in just 1.5 hours. These sessions that they're running in are often only 2 hours apart, and so the speed of working is absolutely essential. And of course from the safety element too, because the cars are doing 170 miles an hour around a track like Monza here, and so quality of work is absolutely vital. From the chassis engineering point of view, the data engineers have to have a different understanding. They're not the guys who are wielding the spanners and doing bits up, taking things off, and responsible for the assembly of the car. They're the people that look through the data, electronics experts. They understand the data, looking through it on their laptops, looking for signs of things not being quite right. And a lot of people start off in low-level championships doing primitive data logging, and then work their way up to something like Formula 2, as we got here, and then ultimately Formula 1.